All right. So we just dealt with limits and everything. So now we're moving into our derivatives and our antiderivatives. And this is another function or another topic that is actually in calculus. This is like the second major portion of calculus. And here in this pre-cal, all we're going to do is just talk about it, touch on it, hit on it a little bit, give you like the basics of it, and then move forward from there. So this is not going to be something that's long and drawn out. It's just the basics, and it should be easy for you. It should be easy. All right, so let's go and take a look at this first page here. And here we're talking about derivatives are used to find the slope of any function. So that could be like a linear function, it could be quadratic function, cubic function, log function, exponential, every type of function, even trig functions. So with this, if you look at all these parts here, I give you the actual symbols for all the different types of derivatives you can have. So you have dy dx, which is the first one. You have y prime. So this symbol right here, is considered. Do a different color. Oh, it changed colors. There we go. So this symbol right here is considered our prime. So we call that y prime. That's y prime. The first one is called dy dx. So literally dy dx. Second one is df dx. And then that's the fourth one is f prime of x, and that's prime again. This is f prime of x. And then it keeps going on forever because it depends on whatever the function is. If the function is g of x, then you have g prime of x. If you have, let's say you have h of x, it's h prime of x. Or it could be dh dx or something like that. So it could be any of those types of things. So the biggest part is understanding that the prime and the dy dx or the d something of dx is your derivative. That's the thing that tells you that's derivative. That's the symbol for derivative. Now, again, with this part, we're not really going to focus all in depth with it. When we get to calculus, you'll see that we actually look at the graphs of it. We actually talk about the slope of the line of the tangent that's tangent to the function using our derivative and all that good stuff. But we're not going to focus in that depth here. The thing that I wanted to do first is at least show you this portion. And this part actually deals with limits. And one of the few things that you will learn, or first things you'll learn in calculus is that we have a definition for derivative, and it is derived from a limit function. And so here we have f prime of x is the limit of f of x plus h minus f of x all over h as h approaches 0. Again, that's the limit of f of x plus h minus f of x all over h as h approaches 0. With that, when you get into calculus, we're going to actually spend a lot of time in that and actually work out the problems using that limit and everything because you want to make sure you're good with how that works and everything. But in this class, we're not going to go there. That's going to take too much time right now. So you'll see that in calculus. So if you're going off to college and doing that, then yeah, you'll see it. And again, calculus here, A, B, B, C, whichever one, you'll see it in there. So here again, this is the definition of derivative. And so again, derivatives just find the slope of a function. It tells us the rate of change also, how a graph changes or a function changes over time. Okay, and some of that you might be like, I don't understand any of that part, what you just talked about. It's okay. When we get to calculus, you'll see it more. You'll understand it more. But here are some rules that I have for you guys. And with it, we have 4 rules for derivatives. And once you start working them out, you'll be like, oh my gosh, it's so easy. I got this. Why do we do this all year? So first one is our constant rule. And constant, this C right here is talking about a constant. That's like saying 2 or 7 or 15 or anything of that sort. when we take the derivative of a constant function, it's always 0. So derivative of a constant function is 0. Derivative of constants are always a slope of 0. Okay. The power rule is the next one. And when we talk about power rule, that means we have an exponent. So here, this is an exponent. So we're talking about a power, an exponent. So we call this power rule. So whenever you have an exponent, all we're going to do is take this number in front, this exponent, sorry, and move it in front. There. So that'd be n x. And then we'll subtract 1 from the original exponent. So here, like we did, we put the n in front, and then we subtract the n minus 1 there. So again, you take the exponent, move it in front, and subtract 1 from the exponent. Okay, not bad. For a constant multiple rule. This is pretty much the same thing as the power rule, but except we have a number in front, a constant in front, let's say like a 5. So for example, again here, you would take this exponent and you move it in front, take it down, and subtract 1 from the exponent. So that's what we did here. We moved it down in front, and we subtracted from the exponent. And then we just leave the constant in front. We don't even touch it. At this point, once we move it in front, then we can multiply c times n and get a number. So c times n will be a number. Bam, easy, simple now. All right, and then the last one, well, last two, sorry, we have sum and difference rule. And all this is saying here is we have two functions being added together. Take the derivative of the first function, take the derivative of the second function, and then we just add them up. Easy. Difference quotient, same thing. You have two different functions being subtracted. So all we do is take the derivative of the first function, take the derivative of the second function, and we subtract the two functions together from each other. Subtract the second function from the first function. That's it. That's all the rules that we have for derivatives so far. And Ken in calculus will get more in depth with it. But right now, this is the only ones we're going to deal with, these 5. All right. So now we're going to go to an example where we actually start using these rules.